Okay, I think she did it. Thank you. All right, so hopefully you all can see my full screen presentation. Welcome to Activate's last formal science team meeting. The project is set to formally end in January, which is when our, it looks like I lost my screen somehow. That's weird. Let me try to take it over again. Okay, so yeah, I'm not sure what happened there. Anyways, so our project is set to have our closeout meeting at NASA headquarters in January of 2025. So this was good timing to have a final team meeting for people to come together, exchange any more notes about data usage, data products, and share some final science presentations. So I will begin with just a brief overview of the project for anyone who's new to Activate, who's joining us, because this is a public meeting, and just to remind team members of certain aspects of the project that could be relevant today. So this is our agenda. We have a number of science talks that's going to occupy the majority of the program. We'll have a small break in the middle, and then we could have a little time for discussion. Hopefully we'll still have that at the end if talks don't go over. And then we do have a bonus talk. Jingmin Li at DLR in Germany had offered to give a talk not too long ago. So we're going to see if anyone wants to stay on, please do for that. We'll call it a bonus talk. So this is recorded because this is an open data workshop. We're going to post it with all of our other team meetings on the ASDC website. And because every person who's speaking will have 20 minutes, I'm not sure how long you each will talk and if Q&A will be enough, if there'll be enough time for it. So I encourage the use of the chat for questions and discussion. So Activate was Earth Venture suborbital mission, part of the third cohort that NASA funded. There's a handful of them, and the goal of Activate is to study aerosol cloud meteorology interactions over the Northwest Atlantic, and we had a very ambitious goal of doing 150 joint flights with 2 aircraft, the King Air and the HU-25 Falcon. Because to study aerosol cloud interactions, we need lots of statistics, lots of flight data to do robust calculations and simulations of ACI. So thankfully, we actually exceeded the goal of that 150 joint flights. We did actually 162 when it was all said and done. So the idea was to fly 2020 through 2022, doing a winter and summer deployment each of those 3 years for a total of 6 deployments. And we have publicly available data that's anyone can go access it. And I encourage anyone who's new to the project to get in touch with the instrument teams before you really get too deep with the data to learn the do's and don'ts. So let's keep going. So we have 3 objectives in Activate. The first one is to study all aspects of droplet activation, looking at relationships between aerosol, CCN, and drop number concentration. Objective 2 is to looking at cloud macrophysical properties. How can we better simulate clouds in this region? And not to just look at aerosol effects on clouds, but the coupling with cloud effects on aerosol. And objective 3 is to assess remote sensing capabilities for all aspects of variables involved with aerosol cloud interactions and even some other variables like wind speed. And so we had a pretty ambitious plan of how to do model data integration as summarized by this nice figure Hailong made years ago. And we've tried to stick to it, and you'll see some of the fruits of those efforts hopefully today. So the 2 platforms are shown here. We had the high-flying King Air that did remote sensing and launched drop zones, and we had the low-flying HU-25 Falcon that did all the nitty-gritty in-situ measurements in the boundary layer of in-situ trace gases, aerosols, cloud droplets, and atmospheric state parameters. Typical flights were about 4 hours, 3 to 4 hours. Beginning with the low flyer, the Falcon, it's important to introduce the payload. For anyone who's new to this, we had an assortment of inlets on the top of the aircraft for trace gases, aerosol, droplet residual particles, and cloud water. We had a series of wing-mounted optical probes to look at particle and drop size distributions going from maybe a micron up to over a millimeter. We had the DLH instrument for really nice water vapor measurements, and the TAMS system in the front of the plane for 3D winds and temperature. Inside of the Falcon, instruments to look at trace gases and various aerosol micro-optical chemical properties. With the King Air, we had the HSRL2 LiDAR, a research scanning polarimeter, and the dropson tube launcher. So the idea is that these two aircraft would fly in spatial coordination for every flight, such that we're getting all the data we'd ideally want in a column at once. And we were very successful in trying to keep these two aircraft coordinated most of the flights. Throughout today, you might be hearing references to what we call statistical surveys or cloud ensembles. That's because our flight strategy was very disciplined, where 90% of our flights we called statistical surveys, where we flew on the top left what we call cloud ensembles, where the King Air would fly level at about 9 kilometers and the HU-25 would do a little bit of stair stepping, going below and above cloud base to characterize droplet activation processes. We have what's called the minimum altitude leg at about 150 meters above ocean surface, and then we'd go up above cloud top and then below cloud top. And we keep repeating these 3-minute legs over and over and over to build statistics. So I think someone has a hot mic, if you don't mind muting yourself. So on the right is the flight tracks in the 3 years, colored by the year. And then at the bottom, I'm showing you an example of what we call process study flights, which were the remaining 10% of our flights. And this is when we went after targets of opportunity, like in this case on March 1st, 2020, a colder outbreak, where the King Air would do a large circle, flying high, dropping lots of dropsons, doing a sort of a crosswind transect. And then within that circle, the Falcon would do stacked level legs called a wall with bookends of spiral soundings. So this breaks away from the mold of the statistical survey, but it was very useful for model studies. And in the afternoon of that day, we went back, fueled up, and we went back to the bullseye of the circle and followed that air mass to see how it evolved over time. So that's what we call a process study flight. We did about a dozen of those. So these are final flight metrics. Again, we did about 162 joint flights. We did several underflights with Astra and Calypso, which are of note. We did, again, a dozen process study flight and launched a whole bunch of dropsons if anyone's interested in that type of data. So this is my last slide. Today we'll be kind of focused on some of the newer science findings from not just team members, but external members from the team who've been using our data, which is fantastic. For anyone who wants to learn more about our data, I highly encourage you to go to this website, the ASTC website, where we've posted lots of tutorials, slides, our past team meetings that walk you through all the details of the instruments and some of the modeling tools. So we've kind of done it before. It's already archived. So that's why we won't be spending a lot of time on it today. We also have this data descriptor paper in this ESSD journal, which again walks you through all aspects of the data and tells you links of where to go download different things. So again, encourage you to go look at those if you're new to all this. And I want to pass the mic very briefly to Michael Shook, who had something to say in the very bottom bullet shaded in yellow.
Hey, Armin, can you hear me?
Yeah, perfect.
Yeah, so this is just to let the data providers know, the folks who've had instruments on the plane. We'll be asking you in the coming weeks to work with the ASTC to kind of zip up and submit your raw data and processing code to the ASTC. This is a EVS requirement, similar to what we've done in previous campaigns, like names and Discover AQ. It's a data preservation activity that's a requirement for these projects. Gao and I are working with the ASTC now to get this process set up, and so you can expect some details from us in the coming weeks about how to do that.
Right. Thanks, Michael. So anyways, that's kind of a fast-paced introduction to Activate. And at this point, we could start the science talks. We could begin with, well, first, let me see if there's any burning questions from anyone. Seems like no. Again, use the chat if you have any that come